Nmap is one of the widely used and most popular tools among cybersecurity professionals, security researchers, hackers and network engineers and learners as well. It is an open-source licensed tool mainly used for performing discover such as ports, operating systems, etc. and auditing or determining security over the network. Nmap is a command line utility which comes pre-installed with Kali Linux. You can also download it for another operating system from this website. The link is in my description box. Nmap also has an official graphical user interface version known as the Nmap. In this video, we will look at the command line version that is Nmap. Nmap can also be used similarly. I also review the Nmap in my next video. Nmap has a scripting engine known as Nmap Scripting Engine, NSE, which is a powerful extension for Nmap which allows various scripts to connect with Nmap and extend its scope and potential to the next level. Nmap has several other components such as a flexible data transfer, redirection, and debugging tool, NCAT, a utility for comparing scan results, NDIF, and a packet generation and response analysis tool, NPing. Why Nmap is a preferred choice? Flexible, supports dozens of advanced techniques for mapping out networks filled with IP filters, firewalls, routers, and other obstacles. This includes many port scanning mechanisms, both TCP and UDP, OS detection, version detection, ping sweeps, and more. Powerful, Nmap has been used to scan huge networks of literally hundreds of thousands of machines. Portable. Most operating systems are supported, including Linux, Microsoft Windows, FreeBSD, OpenBSD, Solaris, Irix, Mac OS X, HP UX, NetBSD, SunOS, Amiga, and more. Easy. While Nmap offers a rich set of advanced features for power users, you can start as simply as Nmap-v-a in the target host. Both traditional command line and graphical GUI versions are available to suit your preference. Binaries are available for those who do not wish to compile Nmap from the source. 3. The primary goal of the Nmap project is to help make the internet a little more secure and to provide administrators, auditors, hackers with an advanced tool for exploring their networks. Nmap is available for free download, and also comes with full source code that you may modify and redistribute under the terms of the license. Well documented, significant effort has been put into comprehensive and up-to-date man pages, white papers, tutorials, and even a whole book. Find them in multiple languages here. Supported. While Nmap comes with no warranty, it is well supported by a vibrant community of developers and users. Most of this interaction occurs on the Nmap mailing lists. Most bug reports and questions should be sent to the MapDev list, but only after you read the guidelines. We recommend that all users subscribe to the low-traffic Nmap Hackers announcement list. You can also find the Nmap on Facebook and Twitter. For real-time chat, join the #Nmap channel on Freenode or EFNet. Acclaimed, Nmap has won numerous awards, including Information Security Product of the Year by Linux Journal, InfoWorld and Code Talker Digest. It has been featured in hundreds of magazine articles, several movies, dozens of books, and one comic book series. Visit the press page for further details. Popular, thousands of people download Nmap every day, and it is included with many operating systems: Red Hat Linux, Debian Linux, Gentoo, FreeBSD, OpenBSD, etc. It is among the top 10 out of 30,000 programs at the Fresh Meetnet repository. This is important because it lends Nmap its vibrant development and user support communities. Nmap First Look. Boot Kali Linux and start the terminal. Type the following command to start Nmap, Nmap. When you start the Nmap with no additional parameters, it will display the options screen for a complete list of options. There are a lot of options in the Nmap and a detailed list can be seen on the manual page. The general syntax for using the Nmap as shown in the above output is Nmap space, scan types, space options, space, and the target specification. For example, we will take an illustration of how Nmap works with a simple example as shown in the above output. Copy it and run it. Output for the above example would look like the following. Basic of port scanning. Nmap is one of the efficient port scanners and by default scan the first 1000 IP ports the target, that is when you use Nmap command directly without conceiving any port or port range. It will scan the first 1000 TCP ports. Nmap provides ports into 6 states, which are open. An application is actively accepting TCP connections, UDP datagrams or SCTP associations on this port. Finding these is often the primary goal of port scanning. Security-minded people know that each open port is an avenue for attack. Closed. A closed port is accessible. It receives and responds to Nmap probe packets, but there is no application listening on it. They can be helpful in showing that a host is up on an IP address, host discovery, or ping scanning, and as part of OS detection. Filtered. Nmap cannot determine whether the port is open because packet filtering prevents its probes from reaching the port. The filtering could be from a dedicated firewall device, router rules, or host-based firewall software. Unfiltered. The unfiltered state means that port is accessible, but the Nmap is unable to determine whether it is open or closed. Only the Xmas Scan, which is used to map firewall rule sets, classifies ports into this state. Open filtered. Nmap places ports in this state when it is unable to determine whether a port is open or filtered. This occurs for scan types in which open ports give no response. The lack of response could also mean that a packet filter dropped the probe or any response it elicited. Closed filtered. This state is used when the Nmap is unable to determine whether a port is closed or filtered. It is only used for the IP-ID idle scan. Various port and flag-based scanning with Nmap. To specify port range, use the following optional parameter. -p. For example, Nmap -ss. This is used for SYN TCP port scan. -p. Specify the port range. Paste the target system. To select all ports, use the following optional parameter. -p-. It will take time, so try it by your own side. For example, Nmap -ss -p- and specify the target. To perform a fast scan with limited ports, use following optional parameter -f. For example, Nmap -ss -f, specify the target. To see the backend processing information, use the following optional parameter -v. For example, Nmap -v -ss, paste the target. TCP SYN Scan. TCP SYN Scan is also referred to as half-open scan. It is quick, default and most popular scan, and has the ability to scan thousands of ports within seconds, considering fair internet connection not restricted by firewalls. It never completes the whole three-way handshake and provides clear results between open, closed and filtered ports. Flag for SYN Scan, -ss. Syntax, Nmap -ss, target, and you can use other optional parameters. Performing TCP SYN Scan, boot Kali Linux and Open Terminal. Use the following command for TCP SYN Scan and check the below output. TCP Connect Scan. TCP Connect Scan detects open ports by completing the three-way handshake process, establishes the full connection, and breaks down connecting by sending the RST packet to the target. If SYN Scan is not used, this is the default scan and doesn't require any superuser privileges. In this scan, we send an SYN packet to target on specified port numbers, and depending upon port state the following can happen. If the port is open, we receive an SYN plus ACK packet back along with the required data. After this, we send the ACK packet and kill connection by sending RST packet. If the port is closed, we receive an RST packet in response. Flag for SYN Scan, -st. Syntax, Nmap-SD, target, and you can use other optional parameters. Performing TCP Scan. Boot Kali Linux and open terminal. Use the following command for TCP Connect Scan and check the below output. UDP Scan. There are some services and protocols which operates on UDP such as DNS and DHCP. UDP Scan works by sending UDP packets to every specified port on the target system. It can work in combination with TCP scans such as Xmas Scan to check both protocols in the same scan. It is usually slower and complex compared to TCP scans, due to which it is usually ignored by pen testers. Flag for UDP Scan -su. Syntax, Nmap-su, target, and you can use other optional parameters. Performing UDP Scan. Boot Kali Linux and open terminal. Use the following command for UDP Scan and check the below output. SCTP Init Scan. SCTP is a relatively new alternative to the TCP and UDP protocols, combining most characteristics of both and also adding new features like multi-homing and multi-streaming. It is mostly being used for SS7 or Citron-related services, but has the potential to be used for other applications as well. SCTP Init Scan is the SCTP equivalent of a TCP Scan. It can be performed quickly, scanning thousands of ports per second on a fast network not hampered by restrictive firewalls like Xmas Scan. Init Scan is relatively unobtrusive and stealthy since it never completes SCTP associations. It also allows clear, reliable differentiation between the open, closed and filtered sites. Flag for SCTP Init Scan -sy. Syntax, Nmap-sy, target, and you can use other optional parameters. Performing SCTP Init Scan. Boot Kali Linux and open terminal. Use the following command for SCTP Init Scan and check the below output. Xmas Scan. Xmas Scan is a type of scan that exploits a loophole present in TCP RFC to put a fine line between open and closed ports. It will not work against any latest version of the Windows operating system and will work for OSes having TCP's RFC 793 implementation. In this scan, we send a TCP frame to a remote device with FIN, push and URG flag set along with Xmas Scan. We will also look at null and fin scan, which works by it. In null scan, TCP flag header is set to 0. In fin scan, only fin bit is set in TCP flag header. In Xmas Scan, fin, PSH and UG bits are set in TCP flag header. Flag for null scan, -sn. Flag for fin scan, -sf. Flag for Xmas Scan, -sx. Syntax, Nmap-sx or N or F, target, and you can use other optional parameters. Performing Xmas Scan. Boot Kali Linux and open terminal. Use the following command for Xmas Scan and check the below output. TCP Mayman Scan. The Mayman Scan is named after its discoverer, Uriel Mayman. He described the technique in Frac magazine issue number 49, November 1996. Nmap, which included this technique, was released 2 issues later. This technique is the same as null, fin, and Xmas scans, except that the probe is fin or AC. According to RFC 793 TCP, an RST packet should be generated in response to such a probe whether the port is open or closed. However, Uriel noticed that many BSD-derived systems simply drop the packet if the port is open. Flag for Xmas Scan, -sm. Syntax, Nmap-sm, target, and you can use other optional parameters. Use the following command for TCP Mayman Scan and check the below output. TCP Custom Flag Scan. This functionality of Nmap allows you to design a TCP scan by specifying TCP flags according to your requirements. -scan flags argument is used to specify custom TCP scan. To use this scan, just combine the symbolic numeric identifiers of each flag and perform the scan. Syntax: Nmap -scan flags, target, and you can use other optional parameters. For example, use following command in terminal. This will choose scan based on SYN, ARG FIN flags. This scan can be performed similarly as per the above scans. Version and service detection with Nmap. Nmap is most popular among other port scanners. It has pre-built functionality which allows you to detect the services running on specific ports and their versions. It can be carried out using version and service scan option in Nmap, which an optional parameter. Flag for service and version scan, -sv. Syntax: Nmap -sv, target, and you can use other optional parameters. Performing service and version scan. Boot Kali Linux and open terminal output. Use the following command for service and version scan and check below. OS detection with Nmap. Operating system detection is one of the best features of Nmap, which allows detecting the target's OS by looking into the TCP/IP stack implemented on the target. Each operating system varies in TCP/IP stack implementations, which allows gathering the information about the operating system just by crawling into stack implementation and looking for differences. Flag for OS detection, -O. Flag for guessing OS detection, -OS scan guess. Syntax: Nmap -O, target, and you can use other optional parameters. Performing OS detection. Boot Kali Linux and open terminal. Use the following command for OS detection and check the below output. In the above example, I use a fast scan flag. Nmap Scripting Engine (NSE). Nmap Scripting Engine (NSE) is one of the most powerful and advanced features of Nmap. It allows us to write simple scripts or use existing scripts for specific jobs using Nmap. These scripts are written in the Lua programming language. According to nmap.org, NSE is designed with following in mind. Network discovery. This is Nmap's bread and butter. Examples include looking up UA data based on the target domain, querying arena, write, or AppNic for the target IP to determine ownership, performing ident lookups on open ports, SNMP queries and listing available NFS or SMB or RPC shares and services. More sophisticated version detection. The Nmap version detection system is able to recognize thousands of different services through its probe and regular expression signature-based matching system, but it cannot recognize everything. Vulnerability detection. When a new vulnerability is discovered, you often want to scan your networks quickly to identify vulnerable systems before the bad guys do. While Nmap isn't a comprehensive vulnerability scanner, NSE is powerful enough to handle even demanding vulnerability checks. When the Heartbleed bug affected hundreds of thousands of systems worldwide, Map developers responded with the SSL Heartbleed detection script within 2 days. Backdoor detection. Many attackers and some automated worms leave backdoors to enable later re-entry. Some of these can be detected by Nmap's regular expression-based version detection, but more complex worms and backdoors require NSE's advanced capabilities to reliably detect. Vulnerability exploitation. As a general scripting language, NSE can even be used to exploit vulnerabilities rather than just find them. The capability to add custom exploit scripts may be valuable for some people, particularly penetration testers. Though we aren't planning to turn Nmap into an exploitation framework such as Metasploit. Flag for NSE, -SC, --script for custom scripts. Syntax, Nmap -SC, target, and you can use other optional parameters. Using Nmap for scripting engine. Boot Kali Linux and start terminal. Use the below command and sample output for the working of NSE. If you have any doubts and queries, write below in my comment section. Thanks for watching.